Next unit where we will be completely calculator driven and we're going to find zeros with the calculators, maxes, mins with the calculator, all that, and it's going to be completely calculator dependent. And in all honesty, there is not a whole lot of time. I mean, Lane's really right, is if you're going to factor to find them, then you're kind of doubling work. And that's kind of the point, too, is it's always easier to factor. That's always our go-to for solving. Remember I told you this whole rest of this unit is about how to solve quadratics different ways. Factoring is always our go-to. It is the easiest way to solve a quadratic. It always is. It's why we focus so much on it. Graphing is definitely not easier, but all I want you to recognize is that if it's graphed for you, or if you graph, then the solutions or the zeros are the places where it's crossing the x-axis, and sometimes if given a graph, we can estimate those, and we can estimate the solutions. Past that, if I give you a graphing problem on the test, or when you get a graphing problem on the test, I'll be looking at that for accuracy, but as far as solve by graphing, I'm more concerned with you understand that the solutions are where it is crossing the x-axis. Does that make you feel better? No. Yes, yes. Okay, so like for instance, give me one. Give me the equation because for whatever reason, 10, 25. So I'm going to start by graphing this. It opens down, right? So I'm going to find the vertex first, opposite b over 2a, which is negative 5. Agree, disagree? Okay. Negative 5, 1, 2, 3, 4, 5. That is my axis of symmetry, yes? All right. So now I'm going to plug that back in to find the y. Negative 25 plus 50 minus 2. Ooh. It's what, say that again, what did you say? Yes, you can do that too. You can do that too. Okay. Now I need another, what's wrong? Well, if you took out a negative 1 like this and you did x squared plus 10x plus 25. So at this point, because listen, what I'm doing is solve by graphing, yes? And if I solve by graphing, I only need to know where it crosses the x-axis. And if I know that's the vertex, all the rest of this is kind of irrelevant. I know it opens down, but I've got the information I need. What's the solution? Negative 5. I mean, technically, if you're asked to graph it, yes. But if you're asked to solve by graphing and you get that the vertex is on the axis, there's really no point in doing all the rest. Give me, which one are y'all? I don't have the thing. So again with the vertex, right, I'm going to do x equals opposite b over 2a. And again, this is one, I would never solve this by graphing. And the reason being, girls, the reason being, if I'm going to have to use my calculator anyway to plug in this nasty fraction, right, I might as well use my calculator to find the zero. And that's what I'm going to show you soon enough. Okay. Gina, do you have a question about this one? That's okay. Remember, homework is only an effort, so you try it, right? You did. Wait, I was thinking like two solutions, one solution. That's what I did. That's okay. That's okay. That's all right. Did you graph it? Yes. Yes. It's okay. It's okay. I didn't even graph them, but I didn't work. Yeah. Yeah. That's okay. You try, right? Yeah. Oh, don't ever spend 2 hours on your homework. If you hit an hour, send me an email. Ms. McGee, I have been working on this for an hour. I'm so lost and so confused. I will tell you to stop, and we will talk about it tomorrow. You sent me a comment? Okay. All right, so I'm going to plug this in. And again, I'm plugging it in, but it's so nasty. But okay, so negative 11 over 2 squared minus 11 times negative 11 over 2 minus, is that 28 or 128? Oh, that's plus 28. I can't read my own writing. What did I do? Okay. When you plug all that in, which is definitely a calculator type deal, what do you get? So what everybody got? No, should get the same. Well, 9 over 4 is 2.25. This is negative 5.5. I bet you messed up on a sign somewhere. Did you keep the first one negative because of the negative in front? And then this became plus? Okay, so if I do this by hand, I get negative 121 over 4 plus 121 over 2 minus 28. 5.5 squared, negative 30.25. This is plus. Is yours plus here in the middle? So here's the thing, and this gets back to order of operations. Whenever you have something like this says, remember, order of operations is exponents first, right? So you square the number first, and then you do the negative of it. That's going to come up a lot in here, and it will throw you if you don't recognize that now. A negative in front like this says that the answer is always going to be negative. And then made the answer to that. Okay. Leah, you're still getting 118 when you do it by hand? That's right. Yes. All right, let me ask you this. Everybody tell me this right now. Can you graph a quadratic? Like what we did lessons 1 and 2. Annoying, but we can do it, right? If I show you a picture of a graph of a quadratic, could you tell me what the solutions are? If I give you the graph, you can tell me what the solutions are. Okay, let's do that. Put a pin in it, we'll come back to it. Good deal? You'll have to graph, but I'm saying okay, so I'll give you some that say graph state the domain and range. You'll have to do that. But then if I give you what are the solutions? Tell me what they are though. 1 and negative 1. What are the solutions? What are the solutions? Can everybody do that? All right, let's move on. All right, buckle up. y'all need a break before we do it? Before I can teach you how to solve with radicals, I need to rewind back to algebra 1. I'm going to assume you need a refresher. In fact, I'm probably going to teach it as if you've never seen it because it's so boring. So if you're bored, I'm really, really sorry. But I want to make sure everyone understands this. Now, what is a radical? Boom. Right? Little house thing, right? Upside down kind of division sign, or not upside down division, but a little, I don't know. I don't know. I don't know how to describe it. But anyway, that's a radical, right? This is called a square root, yes. All radicals are not square roots. There are other roots, but right now you only know about the square roots. We shall get to other roots later. But right now, yes, this is also called a square root. And we're really going to be talking about properties of square roots here. Tell me what a square root does. Divides by itself. Maybe I should ask this a different way. What's the opposite of a square root? A squared, right? A squared is the opposite of a square root. In fact, would you agree with me if I told you that a square root and a squared exponent actually cancel each other out? Would you agree with that? They're doing the completely opposite thing, right? So if I said, what's the square root of 5 squared? You would say that's 5. Also, why the square root of 25 is 5, right? So the square root's looking for a number that multiplies by itself twice to give you what's under there. Is everybody okay with that? All right, so what happens, and this is where we're rewinding back, what happens if I don't have a perfect square under the radical? In other words, okay, it'll give you a decimal. What if I told you to simplify this radical? No decimal. Hey, that's the same thing I do all the time. I do this right here. Do this, do this. You do that little tree thingy. Explain to me what the tree thingy is, what you're doing. You absolutely do. Good job. So here's what I'm doing to simplify. What I want to do, because radicals have this property that says if you multiply under the radical, then you could split them up this way, right? If I multiply under, then I could say the square root of a times b is the same thing as the square root of a times the square root of b. So I can kind of split them up. So we're going to use that thought process to split this up. So we're going to look for the biggest, if I put PS, you know what I'm talking about? Perfect square. The biggest perfect square, I'm going to say that's a factor, or that goes into what's under the radical. Now, I tell students all the time as we work with these, and especially as they get bigger and bigger and bigger, sometimes it's helpful if you just come to the side of your paper, especially if you struggle with this and you write a list of perfect squares. So let's just do that off to the side just to make sure you understand what it is I'm looking for. Start with the smallest. 1 squared is 1, and I won't include 1, I'll start at 2. So 2 squared is 4. 3 squared is 9. Keep going. 25. 36. Keep going. At least be able to recognize up to 13 squared. Those are the most common. And 15 squared. What's 14 squared? Do you see right now? 196. How How about 15 squared? That one comes up a lot for whatever reason, 225. Through there is probably a good thing to at least be able to recognize. You'll have your calculator on these. But anyway, just to recognize, but there's my list of perfect squares. So here's what I want to do. What is the biggest number, if there is one? What's the biggest number in that list that goes into 12 with no remainder? 4. Does everybody agree? 4 times what? So what I'm going to do is I'm going to say, this is the same thing as 4 times 3, right? But because of that property, come on, I'm going to split it up this way, and I'm going to say the square root of 4 times the square root of 3. And what's the square root of 4? 2 square root of 3. Now, I'm also going to make you, and y'all are going to get really mad about this, and somebody's probably going to say a not so nice word to me whenever you get your quiz back and I take points off. You have to have a plus or minus in front. Why? It can be a plus or minus. In fact, up here I would have lost a point because the square root of 25 is actually plus or minus 5. Because remember that definition, what times itself twice gives you that value. Well, what's negative 5 times negative 5? Positive 25, and I still come back to what's under the 5. Is everybody okay? Yes. Did you have an epiphany? Okay. Oh no. That's what we're gonna use. That's what we're gonna use to solve. Remember I told you I had to rewind back and reteach you some algebra 1 so that we could do the algebra 2 stuff. Oh well, now sometimes in her defense, sometimes when you hear something a second time, it makes more sense because you've got. I like to give everyone a benefit of the doubt. I was gonna say I've never even heard her name before. It was. Simplify that. Try that one on your own before I make it harder. I want to make sure you can do everything backwards, forwards, left, right before I throw it in there on the algebra 2 stuff. No, just being silly. No, just go ahead. Simplify that. Simplify that radical. I'm still hearing a little bit of talk about it. I like it when y'all help explain to each other because it starts to. Yes, it really does. All right, what's the perfect square that you use? I heard 9 and 8. I heard 36 and 2. Okay, so this is a great opportunity for me to show you what happens if you don't pick the biggest. So, I mean, you could because you can multiply in any order you want, but technically, like standard form is pretty math let me show you. And let me show you what would happen if you did 9 and 8, okay? Let's first say we do 36 and 2, right? What's the square root of 36? And don't forget your plus or minus. But let's say, for whatever reason, you didn't recognize 36 being a factor, and instead you recognized 9 and 8. What's the square root of 9? 3. Square root of 8. What do you notice about the number that's still under the radical? I can simplify that again. What's the perfect square that I can take out of 8? 4 and 2, right? So 3, and I can make this 4 and 2. Both of these are under a radical. All of this is just multiplication, right? That's what I'm doing. 3 times 9 times, all that's multiplication. What's the square root of 4? So I get 3 times 2. That square root of 2 is still there. What's 3 times 2? Look at what happened. I'm still back to the same answer. It just took me an extra step to get there, right? Yeah. It's easier for you if you use the biggest you can find, okay? Because you don't have to go through the extra. Now, it really, really does, especially when you use. Now, I will say this too. How do you know when you're done? Because you might look at it and go, I'm not real sure. When you can't divide by any other number in that list, you're done. Okay? So if you think you might not have picked the biggest, check back and look. And that'll help you. Okay? Let me give you one more. You try this one. Uh-huh. Yeah, it's not completely simplified. Yes. All right, try that one. Simplify the radical. Foul, isn't it?
No, I just asked.
Oh, it's 5, 7, 8. Okay, so look, but go back and look at this example at what happened. Whenever I put it like this, it's still same process. This is just saying there's already something taken out, but it's okay. We're focusing on what's inside. That's exactly right. Two is not a perfect square, though, right? But you're saying if you divide it by 2, it's 289 a perfect square, isn't it? I don't know. Is it, Thomas? I don't know. Yeah, it is. What's the square root of 289? 17. Multiply, multiply. Everything's multiplied. What goes into 578? He went the other way with just instead of finding the biggest perfect square, he started by dividing by 2 and seeing if he got a perfect square when he divided by 2. Because he knew that number was so big. All right, who found it? Nobody? Nobody. All right, so somebody said 289. What is the square root of 289? 17. Ella, 17. I was thinking that. All right, so 3 times. I didn't mean to bring you out or embarrass you. I wasn't trying to. So 3 times 17 is 51. Is that right? Yes. You times what comes out of it.
Wait,
They're both perfect squares. So with radicals, just like you can split up the multiplication, you can also split up the division. So this is just 6 over 11. Okay. Right. Maybe we should laugh around. Or maybe next break we'll laugh around. All right, rationalize denominator. Several of you said, well, what happens if I went to do the division thing, right? Let's say like this. And the bottom or the top, one of them was not a perfect square. What in the world happened? The radical stays there, but this is a problem. And this is a problem because I can never have a radical in the denominator. Okay. I can't just switch them. Whatever I do, my fraction has to keep its same value. Okay, so if I switch them, then it's got a new value, right? 1 over 4 is different than 4 over 1. But what could I multiply this by to get the radical to go away? The square root of 5. Why is the square root of 5 times the square root of 5, or what does it equal? Square root of 25, which is 5. And in fact, this makes sense also because the square root of 5 times the square root of 5 is the square root of 5 squared. And you told me at the beginning of this lesson that those cancel and they're opposites, right? Isn't that what y'all told me? So it makes sense why it goes away. So to get rid of a radical in the bottom, to eliminate, we'll use a fancy word, square root in denominator. That's the bottom. You are exactly right. I'm going to, whoa. That's an I, it just didn't, yeah. And that's an N. I am going to multiply the top and bottom by the radical in the bottom. That's really confusing. I tried not to put denominator and numerator so many times so it'd be a little less confusing. And then, of course, I'm going to simplify because I always want to simplify. So for this one, I'm multiplying the top and the bottom by what? Square root of 5. Why? This is just, if you like to know your whys, which I do, why can I do that? How come I can do the top and the bottom like that? And it still has the same value. What happens when you divide something by itself? 1, right? It equals 1. What happens when you multiply anything by 1? It stays the same. I'm still keeping the same value because I'm multiplying by 1, right? It's just instead of 1, I got root 5 over root 5. It could be 10 over 10. It could be 7 over 7. It could be Thomas over Thomas. It doesn't matter, right? As long as it's the same thing top to bottom and it's being multiplied. All right.
Or would that just make the person itself equal?
Yeah. I'm going to stop it with this before I show you, so I can show you the algebra 2 part of it, okay? Y'all didn't rationalize in algebra 1?
We did, but it was like
For right now, remember I told you you're probably going to need time tomorrow to practice with this? So time is it? Okay. Do you agree? Give me the definition of a quadratic. Equation-wise, how do you recognize an equation being the variable is squared, the x squared is right? Smiley face or frowny face. Is this a quadratic? What's it missing?
Literally everything else.
It's missing the b and c, right? The bx and the c, but it still qualifies as a quadratic because the x is squared, yes? So if I told you that x squared equals 16, am I asking you to solve a quadratic? Yes, I still am asking you to solve a quadratic. What would you do, maybe? You square root it. You're exactly right. What's the opposite of squaring something? You've already told me is a square root. So what's the answer? You're half right. Why do I need the plus? Why is the plus and minus so important now that you know what you know about graphing? Go ahead. That's right. How about graphically? Connect it graphically. It's two different zeros. Good job, Leah. This is actually a parabola that is crossing the x-axis at both positive 4 and negative 4. That's why there's two solutions. See why I wanted you to understand the graphing a little bit before we got into this? X squared minus 16 be x plus 4 minus 4. Yeah. Hold on. Okay. Not x squared, but if you made it equal 0. So x squared minus 16 would look like this. Now, remember, this is, I told you that I'm showing you all these different ways of solving quadratics. Every quadratic's not going to lend itself to be solved with square roots. So here's how you're going to notice which one needs to be. When you see x one time only, in quotes, we're going to use square roots. And to use square roots, now I have to ask this. When you solved an equation, when you first learned how to solve an equation, how do you know the order that you solved? Close. That's simplifying. What are you talking about? Like if I had 3x plus 7 equals 10. How do you know that you subtract 7 first and not divide by 3? They just told you to do it.
It's been like 7 years of me doing this. It's been great. Yeah, it's left to right, smallest to largest.
Would you agree that solving is the opposite of simplifying? Well, solving is undoing. Is the undoing of it, right? I wouldn't say opposite, but the undoing. So if we follow PEMDAS when we simplify, when we solve, what we need to follow is the backwards of PEMDAS, which is SADMAP, okay? Which is why I'm looking, is there any addition or subtraction being done to the variable? Yes, so I would do that first. Is there any multiplication division being done to the variable? Yes, so I'd take care of that next. Notice parentheses are last as I solve because I'm working my way back into the variable, right? So taking that bit of knowledge that I solve with SADMAP, I'm going to do the same thing using square root. So I'm going to put here, I'm going to use SADMAP. So when you see x only one time in your equation, it's going to have a square. There's going to be a square somewhere in there, but I'm going to solve using SADMAP. And let me show you what I'm talking about. SADMAP. SADMAP. SADMAP, sorry.
Sorry.
Is this a quadratic? Yes. How do you know? There's an x squared. Same thing as x squared. You've been doing it. You just didn't know why you were doing it. You're doing that because of the order of operations. Okay. Looking at this one, do you see that there's only one x in it? It's only written one time. And by one x, I mean there's not a something x squared something x. I only have it one time, right? I'm missing the b term in my quadratic system. So that tells me that I can go backwards on order of operations and I can solve this and get x by itself. So if I'm, this is whenever x is only in there one time. Okay, so how do I get x by itself? What's the first thing you need to do? Minus 8 on both sides. Ooh, rolling now, divided by 7. The only new part here, now, I might not get a perfect square when I take the square root. In which case, that's exactly right. Yes. Y'all have not simplified radicals and all, but you've solved quadratics with radicals? What the actual heck? Okay. Go, you need me to go back? All right, try this one then. Oh, y'all got this for sure. Wow. All right. Backwards PEMDAS. Oh, wait. Okay. Math enter. That'll put your answer in fraction. Well, I don't even understand. I don't even know. All right, what do you do first? Subtract 1. Okay, now everybody listen because here's the part you're going to get mixed up on. There you go. Why? I don't ever want to divide by a fraction. Instead of dividing by a fraction, you know what you're going to do? You multiply by the flip. No, look at there. You would get it, yeah, it would still be right. It's just easier, especially if I didn't have a calculator here, or even if I did, it's easier to multiply by negative 2 over 1 than it is to try to worry about dividing by a fraction. These cancel because reciprocals multiply to 1. So now I have x squared equals positive 80. Now what? All right, separate. What? 16 and 5. What happens if I saw 4 and 20? You keep going. That 20 can go again, right? But if you recognize here 16 and 5, what's the square root of 16? Don't forget your plus or minus or you lose half your points. Yeah, I promise you'll only forget it one time because you'll get so mad at me whenever I take a point off every time you forget that you'll never forget it again. Yes, no, maybe so. Tell me how you feel and what you think. All right, I'm going to set you loose.